Now we will see how sine wave or sine function can be transformed. It can be transformed just like any other. So we'll work with sine, but cosine will work similarly. You just have to remember the main shape of the sine and cosine. So sine goes like this, and cosine starts from the top. It starts at 1, this starts at 0. We'll quickly review how do we transform a given function f of x. What are the things we can do here? So I can have a times f of bx minus c plus d. Do you know what these different things do to the function f? So d is the vertical shift, correct? And b is the horizontal stretch or compression, right? And this is they cause, these are not exactly because I'll explain in a moment, but these are, let's say, caused by. So vertical shift is caused by D, horizontal shift is caused by C, horizontal stretch is caused by B, and vertical stretch is caused by A. So everything is kind of one-to-one except for this horizontal shift, because if we write it like this, because this is not x minus c, right? It is bx minus c. The shift is not c. Shift is given by x minus or x plus. So we have to rewrite it a little bit as factor out the b, and then it becomes x minus c over b plus d. Now we get the horizontal shift. This is the horizontal shift. For an example, if I have 3f of 7x minus 8 plus 9, this is 3f of 7 times x minus 8 over 7 plus 9. So the horizontal shift is 8 over 7. When it is negative, it goes to the right, correct? So when it goes to the right, we take that as a positive shift. If it is, say, f of 2x plus 3, then this is f of 2x plus 3 over 2, but then I can rewrite it as f of 2x minus negative 3 over 2. So now the shift is negative 3 over 2. That means it went to the left. So let's look at how the same things apply for a sine function. A sine function, if we do something like this, 3 sine 2 theta minus pi plus 4. Vertical stretch and vertical shift are very clear. But if I want to know the horizontal shift, I need theta minus, not 2 theta minus, right? So I have to rearrange it. Sine 3 sine 2 theta minus pi over 2 plus 4. What is the horizontal shift? Pi over 2. This is called, for sine, cosine, these trig functions, this is called the phase shift. Phase just refers to the angle, because here horizontal means the x-axis actually is theta, right? The angle. So the shift in angle is called the phase shift. We want to know what happens when we have sine of 2 theta. What does this do to the period? We know that for sine theta, the period is 2 pi, right? For sine 2 theta, what is the period? This is sine 2 theta. And this is 2 pi. This is pi. What is the period? Pi, right? Because this is one cycle from here to here. So the period is pi. What happened here? Because normally the period would be 2 pi, right? For sine theta. Sine theta would go like this. What happened? It got compressed. It compressed how many times? 2 times because of this. It compresses. So instead of like vertical stretch, if you do 2 times, it becomes double, right? But horizontal, if you do 2 times, it becomes half because it gets compressed. So normal period is for sine theta, the period is 2 pi. Since we are compressing it by 2, we will have to divide it by 2. When we multiply the x or the input by something, it actually is compressing by that much. So we have to divide it. If you do 2 times, that means you compressed it 2 times. Now the width of the period is half of what it was before. So we have to do 2 pi over 2. The period now is pi. If I have sine 3 theta, what is the period? 2 pi over 3. Right? Because it got compressed 3 times, right? So whatever was in 2 pi, now there are 3 times as many things in that. So the period became 1/3 of that. What about sine 5 theta? What is the period? If I have sine pi theta, 2 pi over pi, which is 2. If I have sine 7 theta minus pi, what is the period? Remember, we can rewrite it as sine 7 theta minus pi over 7. This is the phase shift. That means it's just sliding it to left or right. That is not changing its period. It's only moving it left or right. So this minus part, there is no theta here, right? You just have to see the multiplier of theta to find the period. This minus or plus, there is no theta here. If there's no theta, that one is just a shift. So the period here is still 2 pi over 7. But if I add here phase shift, so that is 0, 0, 0. And here what is the phase shift? Pi over 7 is the phase shift. 3 sine pi theta minus pi over 2 plus 7. This is the amplitude, right? Normally amplitude is 1. We multiplied by 3, so amplitude is 3 now. Amplitude is positive. Even if this is negative, just flips it, but amplitude is 3. 2 pi over pi equals 2. Phase shift is 1/2. And vertical shift is 7. Okay, so these are all of the common transformations that we will deal with in recognizing, and next time we will look at the graphs also. So going back and forth between them. These are the key characteristics. You can look at the function and tell what transformations have happened, what's the period. And the other side of this will be, we will look at the graph and be able to tell all these things.